Hello again, and welcome back. So, the goal in this video is to start, well, the goal in the next two videos maybe, is going to be to derive two formulas. One for the value of the sine of the inverse cosine of any variable, the other one for the cosine of the inverse sine of an arbitrary variable. And let's go ahead and get started. Let's start by thinking about how to compute the cosine of the inverse sine of a thing, and let's start by just trying to evaluate it at a specific choice of x. Let's try to compute the cosine of the inverse sine of x for a special x, for x equal to 3/5. And this is just to figure out what ideas will go through the process of getting this formula, and then we'll do it in generality. So here, let's do it. Let's compute cosine of the inverse sine of 3/5. So in order to do this, let's think about this inverse thing, the inverse sine of 3/5. Sine inverse of 3/5 is an angle in quadrant 1. It could be quadrant 4, right? Quadrant 4, right? But it won't be because it's a positive number in there. Is an angle in quadrant 1 with sine of theta equal to 3/5, right? That's what inverse sine of 3/5 means. So with that in mind, here's what I'll do. I'll give that angle a name. I'll let theta be the inverse sine of 3/5. Then what do I know? I know two things. I know that theta is an angle in quadrant 1, and I know that sine of that angle is 3/5. So I know that the sine of this angle theta is 3/5. And check it out. I want to know cosine of the inverse sine of 3/5. But hey, that's the exact same thing as the cosine of theta. So all this problem is asking is, if you know what sine of theta is, how do you determine the cosine of theta? And well, shoot, we've done that before. We've done that a few times. So we know two things, right? We know sine of theta is 3/5, and we also know that because the range of sine it's in either quadrant 1 or quadrant 2. But because sine of this angle theta is positive, because 3/5 is positive, it's in quadrant 1. Now, let's use the identity that sine squared plus cosine squared is always equal to 1 to solve for cosine. So let's go ahead and do that. So I'll do one thing that I like to do here. I'll set cosine of theta equal to c, so I don't have to write cosine theta anymore. And I'll plug in sine theta equal to 3/5. So this will give me the equation to solve for c squared plus 3/5 squared equals 1. And we've solved, I think, even this exact equation several times. So I'll go through it maybe kind of quickly. So I need to subtract this thing over to the other side, but as I do that, I'll also square it. So this will give me c squared is equal to 1 minus this thing squared. So 1 minus 9 over 25. So how do you compute 1 minus 9 over 25? Well, you get a common denominator. So this will become 25 over 25 minus 9 over 25, which is 25 minus 9 all over 25. Doing that subtraction, 25 minus 9 is 16/25. So let's just write what this says. So all this was equal to c squared. So now I have the conclusion that c squared is equal to 16/25. If I want to know what c is, I take the square root of both sides. So it looks like c is plus or minus, because I'm going to undo a square by square rooting, the square root of 16/25. Do you see any perfect squares under that square root? Of course you do. So that means you can get rid of the square root. Just write 4/5. Right, the square root of 4/5. So the cosine of the inverse sine of 3/5 is the cosine of theta, which is the thing that I called c in the previous step. And I just computed c was plus or minus 4/5. Positive or negative, though? What quadrant is this angle in? It's in quadrant 1. In quadrant 1, Is cosine positive or negative? It's positive. So that means that the cosine of the sine inverse of 3/5, also known as the cosine of this angle theta, will be positive 4/5, not negative 4/5. All right, so let's actually do that same computation in another way. Let's do it by thinking about triangles instead of by thinking about algebra. The logic will be largely the same. So, same strategy. I want to evaluate the cosine of the inverse sine of 3/5. So I'll let theta be the sine of 3/5. Then sine of theta is 3/5. And theta is in quadrant 1. Using that fact, the fact that sine of theta is 3/5 and theta is in quadrant 1, that means I can draw this angle in a right triangle. So if there's a right triangle, I know that sine theta, which is 3/5, will be opposite over hypotenuse. Oh, neat. Well, that's handy. That means 3/5 is opposite over hypotenuse. Now remember, I can rescale these right triangles. So I don't know exactly what all these side lengths are, but I know the ratio of this side to this side is 3/5. Well, one way of arranging that is opposite is 3, hypotenuse is 5. And I want to know the cosine of this angle theta. So cosine of theta is adjacent over hypotenuse. So I want to know this side length. And how do we find that side length? Let's give it a name. Let's call it, I don't know, A for adjacent. I can use the fact that this is a right triangle. So a squared plus 3 squared equals 5 squared. Solve that for a. Well, 5 squared is 25. And I need to subtract 3 squared, which is 9. A squared is 16. So a is, this is a triangle, the square root of 16, also known as 4. So now the cosine of this angle theta, so I just computed that that was 4, is adjacent over hypotenuse. So it will be adjacent divided by hypotenuse is 4/5. So the only thing that might go wrong is if you try to plug in negative number. So if you tried to follow the same strategy to compute cosine of the inverse sine of negative 3/5, you might wind up getting confused. You can still make it walk though. Right, because what would you need to think about? You would need to say, well, this angle theta is in either quadrant 1 or quadrant 4. Because the sine is negative, it can't be in quadrant 1, so it has to be in quadrant 4. So the triangle needs to point like this. And then you can play the same game. So that means this length, which is going down, is 3, but in the negative direction. This length is 5. You could still compute that this is 4. So you'd still get the same answer of 4/5. You just have to draw a slightly different triangle. So now let's try to get a general formula. There was nothing special about 3/5 except that, the numbers worked out well, so we wound up with a pretty looking answer. But that doesn't matter. Not all numbers are pretty. Sorry, the cats are agitated right now. Let's try to do the same computation. Let's try to compute the cosine of the inverse sine of x for absolutely any number x. So let's just write things down. Let's let theta be equal to the inverse sine of x. Then I know that the sine of theta is equal to x, and theta is in either quadrant 1 or quadrant 4. Well, let's try to do it. So I'll do it to use both of the arguments here. I'll use the Pythagorean identity, and I'll also use some right triangle ideas to think this through. So let's do it. Let's compute the cosine of the inverse sine of x. So right, that means that I want to compute, I want to know cosine of the inverse sine of x, but I've given, the inverse sine of x. I've given that a name. The inverse sine of x is equal to theta, so I can put a theta in here because theta is the inverse sine of x. So this is the same thing as the cosine of theta. So what do I know? I know that the sine of theta is equal to x, and I know that theta is in quadrant 1 or quadrant 4. So let's go ahead and do that. So I'll use the Pythagorean identity. The Pythagorean identity tells me that cosine of theta squared, the thing that I would like to know, plus the sine of theta squared, the thing that I do know, that's equal to x, is equal to 1. So that quantity is equal to x. Let's set cosine theta equal to c. So this equation will become c squared plus x squared equals 1. And I want to solve for c, right? That's the thing that I would like to know. So that'll give me c squared is equal to 1 minus x squared. Take the square root of both sides. I'll get c is equal to plus or minus the square root of 1 minus x squared. Now theta is in quadrant 1 or quadrant 4. So let's use that. Theta in quadrant 1 or quadrant 4. Well, that means that cosine is positive. And remember, cosine theta is c. So that number is positive. So c is positive the square root of 1 minus x squared. We've just done a computation. The cosine of the inverse sine of x is always the square root of 1 minus x squared. And let's also do this using the right triangle perspective. So maybe I'll be a little bit risky. I'll assume that x is positive. So let's assume x is positive. So theta is in quadrant 1. Well, then I have sine of theta equals x, which is equal to x over 1. So if you wanted to draw a right triangle with an angle of theta, here it is. It looks like the opposite side should be x, the adjacent side can be 1. Do you think you can solve for the, so opposite side is x hypotenuse. Do you think you could solve for the adjacent side? Yeah, I think so. You'll end up saying the adjacent side is equal to the square root 1 minus x squared. So cosine theta is the square root of 1 minus x squared over 1, also known as just the square root of 1 minus x squared. Either way, we get the same formula. That completes one of the goals. That tells me that for every x, the cosine of the inverse sine of x is always equal to the square root of 1 minus x squared. Cool. So there's one last thing that I'm going to do here. I'm going to check this formula by using it to make a computation that we already know the answer to. So I already know that the cosine of the inverse sine of 3/5 should be 4/5. We've already done that computation. But we also have a formula. I should be able to plug in this for x into this formula in order to get an answer, and it should be the same. It should also be 4/5. So let's see if that actually works out. So let's try to compute the cosine of the inverse sine of 3 over 5. So that means I'm going to plug this in for x into that formula. Let's do that. That should be the square root of 1 minus x, which is 3/5 squared. So that'll be the square root of 1 minus, how do you square a fraction? Well, you square the numerator and square the denominator. 1 minus 9 over 25. Carrying on, 1 minus 9 over 25 is the square root of 25 minus 9 over 25. Right, so in that step, I got a common denominator, and I subtracted fractions. 9 minus 25 is 16 over 25. Do you see any perfect squares? Of course you do. The denominator had to be 25, so I knew that that would wind up being there. And the numerator is 16. 16 is 4 squared, so the numerator is 4. So yeah, I get the same answer again. It checks out. In the next video, what I'm going to do is I'm going to do some similar stuff, But instead, I'm going to compute the sine of the inverse cosine instead of the cosine of the inverse of sine. It will turn out to be remarkably similar.